We're going to finish up this unit looking at graphing quadratic inequalities and solving quadratic inequalities. Now, there's a couple ways to think of this. If we have a y greater than or equal to our quadratic here, we know it's going to be like graphing our normal quadratic functions, except we're going to also have to do some shading. So once again, to review that, you want to find your axis of symmetry, so use negative b over 2a, and we get this. And then you want to go ahead and make yourself a t-chart. Choose 3 numbers on each side of your t-chart, and then plug each one of these numbers into your original problem up here to figure out the y values. So if you plug in 0, 0 here, you get 2. Plug in negative 1 would be 1, plus 3, plus 2, and so on. Now, we had also said that you can go ahead and make this chart on your graphing calculator. In the earlier chapter or units, videos showed you how to do that. So we can just plot that. So if you plot those points, we get our quadratic curve. We know it's going to be dotted because it's only a greater than. It's not greater than or equal to. If it was greater than or equal to, we'd have a solid curve. Now there's a couple ways we can figure out our shading. In this case, you can see that we're shading above. When y is on one side by itself, your inequality sign you can use to help you figure out where to shade. We want the y values that are greater than that, or the y values that are bigger than our curve. Well, the y values bigger than our curve are above that. A second way you could do that is to try a point that's not on the edge of your curve, like 0, 0. I like that because it's easy to work with. If we take x being 0, y being 0, and we plug this in, we want to see if we get a true statement. Well, when we plug in 0, 0, we then end up getting 0 greater than or equal to 2. So we tried this point, and is 0 greater than 2? No, that's a false statement. So that means this point here doesn't work. So we'd want to shade on the other side of the curve, which would be over here. So that's a second way you can figure out how to shade. So with that in mind, try this one on your own, and then watch the video. Negative b over 2a, you get 2. Make yourself a t-chart, choosing 3 numbers on each side, doing it either by hand like this, plugging each number in, or using your graphing calculator. It's greater than or equal to, so it's going to be a solid curve, so we plot our points. We get this here. It's greater than or equal to, so if we're here, we want to be shading above that because we want the y values larger than that, and y goes up and down, so we're going to shade up. So that's shading on the outside. If you tried that point, 0, 0, you try the point 0, 0, we get y is greater than or equal to 2, which is not the case, so that means we want to be shading on the other side of where 0, 0 is. So we can also go ahead and solve x squared minus 4x plus 3 greater than 0 from looking at our graph. So to do that, to solve this, looking at our graph, we want to just go ahead and graph this here. So you do the negative b over 2a, make yourself a t-chart, and we get this. Now that's what your function looks like. Oh, just a second here. I see that this should be, there we go. This should be an equal sign here is what we're really trying to graph. And that's going to help us with this. So we want to know when is our quadratic function greater than 0. That's our original problem. When is the quadratic above 0? Well, y equals 0 is your x-axis. We want to be above. Well, when we look at this, we are above right in this area here, and we are above in this area here. So in other words, when we are to the left of 1, we're above. So x being to the left of 1, our parabola is above. X being to the right of 3, our parabola is above. So we have 2 different areas that work for us. And this should be an or statement here because we have 2 regions that work for us. So we can write this then as 2 totally separate inequalities joined by an or statement, where we're to the left of 1, or work to the right of 3. Both regions work. See if you can then try this one on your own. So we get our t-chart, graphing your t-chart. We get this. We want to know, when is our parabola less than 0? When is our parabola below the x-axis? Because that's what y equals 0 is. Well, when are we below? We are below just this little bit right here. Really, we're just below, in between -2 and -3. So we are, how would we write that? We could write that, since it's one region, it's one inequality, where our variable is between -3 and -2. And that's what we have written here. Now notice our original problem was only less than, so we are going to have -3 less than x less than -2. Now we can also solve quadratic inequalities like the last two using algebra instead of looking at a graph. The graph is nice because it gives you a nice visual picture of what's going on. But let's look at a second way you could do that. I'm going to basically solve the equivalent equation. So I'm going to go ahead and get it equal to 0. Now I could either solve by factoring, completing the square, quadratic formula. In this case, it does factor nice. Two things multiplied together to give me 0. I set the first thing equal to 0 and I solve that. Or I set the second thing equal to 0 and I solve that. Now, these are going to give me the 2 points on my number line, which breaks my number line into regions that work and regions that don't work. So I'm going to put my number line down. And by the way, these 2 points that we have here would also be where my parabola would cross the x-axis back here. So there's a number line underneath here going from left to right. I need to try a number in each one of these regions into my original problem to see if it makes it a true statement. Now, I could try this here. I could also easily try this. And this would then be my less than or equal to here. Now, if I try a number over here, like say -3, -3 minus 1 would be -4. So I get a -4 here, put a -3 here, plus 2 would be a -1. Is a -4 times a -3. A negative times a negative is not going to be less than 0, so I'm not going to shade over here. I could try a number over here, say 10, or 2, or 3. I could even try pi, anything larger than 1. If I did try 10, I'd have 10 minus 1, which is 9. And 10 plus 2, which is 12. Is 9 times 12 going to be less than 0? No, so I'm not going to shade there. I'm going to try a number in between -2 and 1. If I did that, I could try 0. Plugging in 0 here, I get a -1. Plugging in 0 here, I get 2. Is a -1 times a 2 going to be less than 0? A negative times a positive does work because it gives me a negative here, and a negative is less than 0, so I'm going to shade in between. Being less than or equal to, I'm going to include my 2 endpoints. So I can have one region. I can write that as one inequality, and I'm shading in between two numbers, so I need to put my variable in between two numbers and shade there. Go ahead and try this one here on your own and then watch the video to see if you agree. Add 6. In this case, we get it set equal to 0. We could factor it, or we could use a quadratic formula, but it factors easily. Set your first factor equal to 0 and solve it. Second factor equal to 0 and solve it. These are the 2 points that we're going to put on our number line that break our number line up into regions that work and regions that don't work. So I try a number over here to the left of -3. And I'm using the factored form that I had up here, because then all I have to do is just to decide if it's positive or negative. I could use my top one up here, but then I'd actually have to work out what the value of this left side is, and then see if it worked. So if I try a number over here like -4, -4 plus 3 is -1. -4 plus 2 is negative 2, and negative 1 times negative 2 is positive, and that's what I'm looking for. So I tried a number over here, made it true, so I'm going to shade over there. Try a number like, I don't know, negative 2.5. Negative 2.5 plus 3 is positive. Negative 2.5 plus 2 is negative. Positive times a negative is not going to give us what we are looking for, so I'm not going to shade them in between. Try a number over here like 0. So then I would get 3 here, which is positive, 2 here. 3 times 2 is positive, so it does work because that's what it is I'm looking for, because I wanted numbers greater than 0. Now we have two totally separate regions that work for us, so I need to write this as two totally separate inequalities joined by an OR statement. So I have all the numbers to the left of negative 3, and I would need all the numbers to the right of negative 2.